Section 1.4, Quadratic Equations. From the section 1.3, we talk about the linear equation in one variable. Linear equation means we do have a first degree in the variable of x. And this time, when we talk about the quadratic equation, that means we do have a second degree. Okay, x squared. This is called quadratic equation. And the standard form will be ax squared plus bx plus c equal to 0. We talk about how to take care of quadratic equation in the review chapter. We know how to do the factoring. Okay, second degree equation. All of this, we call this is quadratic equation. We do have the x with the degree 2 here. Okay, second degree, and second degree. Zero factor property. If a and b are complex numbers with a times b equal to 0, then a equal to 0 or b equal to 0, or both equal to 0. Okay. For example, we have a 10x squared plus x minus 2 equals 0. We only have a one variable, and this is the second degree. So this is a quadratic equations. First, I want you guys use your x method or any way to factor this quadratic equation. You should get this. Okay, we call 2x plus 1, this is the factor. 5x minus 2, this is also the factor. And then we're gonna apply the zero factor properties. A times b equal to 0, then a equal to 0 or b equal to 0. Okay, so once we have this factor, you could consider this is a times b equal to 0. So we could break it down, a equal to 0 or b equal to 0. And then we're gonna solve for x. You should get x equal to -1/2 or x equal to 2/5. So we say the solution set for this quadratic equation will be -1/2 and 2/5. Okay, square root properties. A quadratic equation of the form. We only have a one variable here, okay? K, you could consider this as the real number. So x squared equal to k. How can we solve for the x? From your book, they do it like this way. They subtract the k and then factor out. This is by the formula a minus b times a plus b equal to a squared minus b squared. And then use the zero factor property to find it out. Okay, or I'll be doing on this way. Okay, so I will have an x squared equal to k. Instead of subtract the k, I will just take the square root for both sides. Okay, when we take the square root, this is an even number, we're gonna add plus minus here. Okay, so my x is gonna be equal to positive square root of k or negative square root of k, just like this guy. Okay, right? Okay, so this is the square root property. Okay, 1 plus 1 minus for the square root of k. Okay, you could apply the square root property and then work on the example 2. So first one, we're gonna take the square root for both sides and then add the plus minus. And then we can simplify the 29 here, right? So this is gonna be my final answer. Okay, B. We can have the complex number, okay, for this kind of the questions. So when you take the square root for both sides, first as plus minus, and then remember what is a square root of -144? Let me do it here. x squared equal to negative 144. Take the square root for both sides. Make sure you add plus minus. And this has become your x. Okay, so square root of negative 1 times 144. Okay, right? So this is gonna be plus minus I. And square root of 144, that will be 12. So x equal to plus minus 12i. Okay? Okay, right? X plus minus 12i. And then C. We have a x minus x squared equal to 24. Don't break it down, okay? Don't distribute it, okay? We're gonna keep this guy, x minus x. So we're gonna take the square root for both sides, add the plus minus, and this one cancel out square root with the square. So I left with x minus x plus minus square root of 24. How can you break it down? I could do 4 times 6, right? So x minus x equal to square root of 4. That would be 2, right? 2 vertical 6 here. And then we're gonna add x for both sides. So x equal to x plus minus 2 square root of 6. We do have a 2 solutions here, okay? Make sure you guys understand how to rewrite this guy. So we have a x plus 2 square root of 6, or x equal to x minus 2 square root of 6. So this is gonna be your solution. Okay? Solving quadratic equations by computing the square. You guys can follow the step here. If the coefficient of x squared is 1, go to the step 2. So this is good. Coefficient of the x squared. This is positive 1. So this is good. Then go to step 2. Otherwise, divide both sides of the equation by the coefficient of x squared. Isolate all the variables terms on one side of the equation. So isolate all the variable terms. So I keep all the x on your left hand side, and I just put like the constant terms to another side. Step 3. Compute the square for the resulting binomial by adding the square of half of the coefficient of x both sides of the equations. So this means you're gonna look at the x here. The coefficient of the x will be the b, right? So we're gonna add b over 2 squared for both sides. Whatever you have the b here, you're gonna do b over 2 squared. When you add it on your left hand side, you're gonna do the same thing on the right hand side. And then factor the resulting perfect square trinomial. So we're gonna factor out this trinomial. This is gonna be the perfect square, okay? So you should get x plus b over 2 squared here. And then on the right hand side, you could just combine the 9 terms though. Okay, this is the idea of computing the square method. And then at the end, we're gonna use the square root property to solve for the x. Okay, at the end, this guy, that will be similar to the example of this one. Okay, x minus x, just like here, square, equal to a constant. This is gonna be the constant when you combine it. Okay, so when this is gonna be the positive. When you have a negative here, pretty much about the same thing. Isolate all the variable terms on one side, and then we're gonna add b over 2 squared. Okay, that is supposed to be negative b over 2, and then you take square. But when you take square, the negative goes away. Okay, if this is negative, this is gonna be negative. If this is a positive, this is gonna be positive. And then we're gonna factor out x minus b over 2 squared. Okay, this is the method of computing the square. Okay, let's try to do it together. So x squared plus 10x plus 4 equal to 0. First, we're gonna isolate the variable. So I have a negative 4 here. And then we're gonna look at your b, okay? The b will be equal to 10. So what we want to add, we're gonna do b over 2 square. We're gonna add it for both sides. So I'm gonna add b over 2 square for both sides. Okay, when you factor out this one, that's a trick though. You're gonna do x when you have a plus, and you only copy 10 over 2 here. So you're gonna see we have x plus, only take 10 over 2 here. 10 over 2, that will be equal to 5. And then the square here. Okay? And then equal to, take care of the right hand side, negative 4 plus 10 divided by 2 is gonna be 5. 5 squared is gonna be 25. So now I have x plus 5 squared equal to 21. Okay, that will be similar to the previous example. We're gonna use a square root property. Take the square for both sides. Make sure you have the plus minus here. So x plus 5 equal to plus minus square root of 21. And then you're gonna subtract 5 for both sides. So done. This is gonna be your final answer. This kind of the question, you can't use the x method because you do have the square root here. Okay, so we're gonna teaching computing the square method and also the quadratic formula. I need you guys know how to do both of the method. Okay, isolate the variable of x, and then you're gonna add b over 2 squared. I could do one more step here. I take care of it. 10 divided by 2, take square is gonna be 25. And then you could use the x method to do the factoring. Or you could just like what I say here. You just got x plus, copy the 10 over 2 here. Square is gonna be outside. Okay, or you could double check your work. You could distribute x plus 5 square to see. You gotta go back to this one. Combine the 9 terms. Use the square root property. Okay, so that will be your solution. This is called computing the square method. Okay, another example. Make sure you're gonna double check when you're working on the computing square method. The coefficient of x squared has to be positive 1 here. Okay, if not, then you need to divide it by 2 for the whole equation. Okay, I move the constant to another side, and this is not the positive 1. So I'm going to divide it by 2 for each term. So divided by 2, I'm going to get x squared. Divided by 2, I'm going to get 4x. Divided by 2, I have a 3 over 2 here. Okay, now we're going to add b over 2. This is going to be your b. b over 2 squared, which is going to be 4 over 2 squared. And then factor out this guy. You're going to have an x minus 4 over 2, which is going to be 2 squared here. Okay, this is 4 divided by 2. 2 squared is going to be equal to 4. Okay, get the same denominator, times 2 times 2. So 4 times 2, 8. 8 plus 3 is going to be 11. And then use the square root property. Okay, make sure you add the plus minus sign here when you take the square root for both sides. And then you're gonna add 2. So that will be your final answer. This one, they want you to rationalize. Okay, so you're gonna times RAD2 over RAD2 here. Make sure there's no radical on the denominator. So on the top, you're gonna get square root of 22 over 2. Okay, C. Try to do it by yourself. Make sure you have the positive 1 on the coefficient of x squared. Okay, first, subtract 5 for both sides and then divide it by 4. Okay, this time your b will become 1/2. So 1/2 divided by 2. Okay, let's do together here. Okay, now I have a x squared minus 1/2 x. I'm gonna add something equal to negative 5 over 4. So your b equal to 1/2, right? And then we want to add b over 2 square. So what does that mean? So 1/2 divided by 2, which is gonna be 1/2 division divided by 2 means 1/2 multiplied by 1/2, which is gonna be 1 over 4. Okay, so when you have the fraction, you could think about what you just multiply by 1/2 here. Okay, just like here. So this is what we want to add. 1 over 4 square. 1 over 4 square. Okay, then we will have a x minus 1 over 4. So x minus 1 over 4 square. That will be equal to negative 5 over 4 plus 1 over 16. Okay, LCD will be 16, so you times 4 here, times 4 here. Okay, so that will be negative 5 times 4, which is negative 20. Negative 20 plus 1, negative 19 over 16. Okay, right? Take the square root for both sides. So x minus 1 over 4 equal to, we do have a negative numbers here. Okay, so that will become the I. We have a plus minus I, and then square root of 19 over square root of 16, which is going to be equal to 4. And then we're going to add 1 over 4 for both sides. So 1 over 4 plus minus I, RAD 19 over 4. That will be your final answer. Okay, check the word. Okay, divided by 2 means times 1/2. Okay, that's what we get for final answer. Okay, that is a completing the square method. Okay, make sure you guys know how to do it. For sure, that will be on your chapter exam. Quadratic formula. We're still working on the quadratic equation in the standard form, ax squared plus bx plus c equal to 0. Okay, and then this is the quadratic formula. X equal to negative b plus minus square root b squared minus 4ac over 2a. And keep in mind that this line is talking about the whole thing. The whole thing here divided by 2a. Some students only focus on here. Okay, Division line is going to be including the negative b here. Look at this example. We have a 3x squared plus 5x equal to 2. And I want you guys to use the quadratic formula. So first, we want to determine what is your a, b, and c. So look at the equation here. We have to rewrite it to the form of ax squared plus bx plus z equal to 0. Ax squared plus bx plus c equal to 0. Okay, so we're going to subtract 2 for both sides here. Now, you're going to determine what is your a, what is your b, what is your c. A, that will be equal to 3, b equal to 5, and c, make sure including the sign here. That will be negative 2. Okay, write down the formula. Now I want you guys try to plug into the formula and simplify it. You plug it in, you should get this guy. Make sure when you have a negative number, it will be better when you put the parenthesis. Okay, remind yourself that's a multiplication. Simplify. Okay, right? So this is a 25 minus negative 24. That will become 49. Okay, simplify this guy. So that is integer, negative 5 plus minus 7 divided by 6. So I want you guys separate into two. One is negative 5 plus 7 divided by 6. And one is a negative 5 minus 7 divided by 6. So you should get 2 over 6 or negative 12 over 6. Simplify it, you should get these two answers. Okay, now, once you get your answer, how can I check my work? I should plug in back to the original equation, this one. Okay, plug in x equal to 1/3 into here to see if it's gonna be equal to 2. Same idea for x equal to negative 2. Plug in here to see if you're gonna get the true statement. So try to check your work. Check both of them. Okay, plug it in. Alright, you take square here, so it's going to be 1 over 9. Okay, so simplify this guy. And then 5 times 1, you're going to get 5. So they have the same denominator. You could add up the numerator. 1 plus 5. That will be equal to 6 divided by 3, which is going to be equal to 2. This is a true statement, right? This is good. Okay, do the same thing when x is equal to negative 2. Put it back into the original equation. Okay. So this is a true statement. So we get the correct answer. Okay, one more time and the exam, I need you guys remember this formula. Okay, when you have a negative, try to put on it with the parenthesis. Okay, right? So this is a quadratic equation using the quadratic formula. Now, the cubic equation. So we do have the equation like here, x cubed plus x equal to 0. Okay, and the highest degree of the term is going to be 3 here. So that's why we call this as a cubic equation. Okay, look at this example. X cubed minus 125 equal to 0. Okay, for this one, we want to apply the formula. remember you guys learned this formula, a cubed minus b cubed. We have a two formula. I just write it down first. A plus b, a squared minus ab plus b squared. Okay, and f another one, a minus b, a squared plus ab plus b squared. Okay, so we're gonna use the second one. X cubed minus 125 equal to 0. So I have, this is gonna be 125. I could break it down, divided by 5, divided by 5, divided by 5. So I have a 5 to the power of 3 equal to 0. Okay, right? So I'm gonna use the second formula. I'm gonna use this one. So first, a minus b. Your x will be your a. Your 5 will be your b. So the first one, I will have an x minus 5. Okay, and then x squared plus a times b. So I have a 5 times x here. Plus b squared, which is going to be 25, equal to 0. Okay, right? And then we're going to use the zero product properties. So x minus 5 equals 0. Or x squared plus 5x plus 25 equal to 0. And this is going to be x equal to 5. I have a first answer. Second one, this one, you won't be able to solve it with the x method. Okay, this guy, you have to use the quadratic formula. So my a is going to be equal to 1, b equal to 5, c equal to 25. And then I'm going to plug it in. So negative b plus minus square root b squared minus 4ac over 2a. And then simplify it. X equal to negative 5 plus minus. This is become 25 minus 100 over 2. Okay, subtract it. Negative 5 plus minus square root negative 75 over 2. Okay. Okay, 75. Let us break it down to see divided by 5. 15. Okay, right? So 5 times 5 times 3. So that is equal to negative 5 plus minus. I have a 2, 5 here. Okay, let me wait one more step. Square root of negative 1, that's equal to I. And then I left with 5 squared times 3 over 2. Okay, so x is going to be negative 5 plus minus. 5 squared and square root cancel out. So I only have a 5i wet 3 over 2. Okay? So you could keep this one as a final answer, or you could write it down like negative 5 over 2 plus minus 5i wet 3 over 2. That will be another 2 answer. Okay, every time when you guys using this formula to factor out the quadratic equation, this part you won't be able to factor with the x method because this is a complex number. Okay, you may want to use the quadratic formula to factor it. Okay, go back to here. Okay. So another one, solve v equal to 1/3 pi r squared h for r. Use plus minus. when taking square roots. Okay, so we want to solve for the r in here. So first, we're gonna multiply by 3 for both sides. Okay, times 3 times 3. Now you want to get out of pi and the h, so you want to divide it by pi and h for both sides. Okay, right? And then we want to solve for your r, so you're gonna take square root for both sides. When you take the square root, make sure you add plus minus. And then we try to rationalize the denominator, so we're gonna times square root of pi times h. Square root of pi times h. So final answer. The discriminant. The quantity under the radical in the quadratic formula b squared minus 4ac is called the discriminant. The discriminant, we usually use the triangle to represent it. Okay, look at the quadratic formula. Okay, inside the radical, this guy, b squared minus 4ac, this is called the discriminant. The discriminant, if you have the quadratic equations and you want to determine how many number of the solutions they have or what type of the solutions they have, we're gonna use the discriminant. For example, let's say I have a quadratic equations, x squared minus x minus 6 equal to 0. Okay, I could use the x method. Solve it, that will be x minus 3, x plus 2, and then x minus 3 equal to 0, x plus 2 equal to 0. So x equal to positive 3 and x is gonna be equal to negative 2. So this one, we do have a 2 solution. So without like calculating, find out the x here, I could use the discriminant. So in here, I could use the discriminant b squared minus 4ac. So my b squared would be negative 1 squared times 4 times 1 times negative 6. Okay, a is 1, b is negative 1, c is negative 6. Now I'm gonna calculate. So that will be 25. Okay, so my discriminant is gonna be equal to 25. 25, this is a positive, this is a greater than 0, and also this is the perfect square. Okay, if I put like on square root on it, I'm gonna find it out, that's gonna be equal to 5. Okay, this is what he say, positive, perfect square. Then you do have a 2 number of the solutions, and the types of solutions that will be rational. Okay, second one, positive but not a perfect square. So I just make up the numbers. Okay, we're gonna go through the example. If I find my discriminant, it's gonna be equal to 37. Okay, this is a positive greater than 0, but not a perfect square, because when you have a square root of 37, we may need to use the calculator. If this happen, then you do have a 2 number of the solutions, but the number of the solutions will be irrational. Okay, irrational means you do have the radical here. And then if you have the discriminant equal to 0, then they only have a 1 double solution. It means the solution is going to be repeated, and that's a rational. And if your discriminant is going to be negative, I may have the negative 21 like that. Okay, this is a negative. When you have a square root of the negative 21, then we're gonna get the complex number. Okay, so this is what I say. Like when the discriminant equal to negative, you do have a 2 number of the solutions. And the types of solutions gonna be non-real complex number because of the square root of the negative here. Okay, let's try to do some example together. This one, figure out what is your A, B, and C. You should get that, right? And then we're gonna find the discriminant. Okay, find out b squared minus 4ac, plug it in. You should get this guy. That's a equal to 0, right? Equal to 0 means they only have a one rational solution. You can try, use the X method to factor out this guy, right? You should find the repeated solution. Okay, next one. I want you guys try. Find the discriminant. Only find the triangle b squared minus 4ac. Okay, we write this equation. Write it down. What is your ABC? And then the discriminant equal to negative, right? Negative means they do have a two solutions and it's a compressed solution. Okay, last one. Write it in the standard form. And then your ABC here, right? So the discriminant, that would be equal to positive 92. And this is not the perfect square. So we have a two irrational solution. Okay, that's it.